Hey, Patrick here. Welcome to my Python tutorial on the turtle module, first lesson. As I said, even children like Python with the little turtle. And what we are going to do today is I'm going to show you how to make graphs like this one or with this one. And you see there is a little turtles which make it fun for, I guess, children. But still, I think that it's a very good module if you want to start learning some programming in Python. And basically, as always, every time I use a specific module or library, you can always find it on GitHub. Like if you go here on that website, it will open this. And then you get the documentation of the Colab Turtle Plus module. So it's written Colab here because it means that this is the turtle module, Python turtle module that works with Google Collaboratory, the cloud space that we are using. And plus, because it's a second version, there was a previous version by Tolga Atam, and I'm using the new version here, the extension of the original program. And as always, you can see in case you think, well, like, why is it that this guy is introducing all those lines? Well, I have seen them in the documentation. In the documentation, they say, well, you should install uh, the module this way or the library this way. Uh, and, uh, and then you should import the module this way. Okay, so that's basically what I do here. Okay, so we can install it. I already installed it before, but uh, and actually you can see here. Maybe I need to reconnect. You can see that it is said that the requirement is already satisfied because I have installed it just before class. Okay, so. Once it is installed, okay, I still need to import all the modules from that library. So you can see that I'm simply following this code line that you see. And then, if you read the documentation, you are going to see information on how to do plots or graphs. So, I basically follow this tutorial in order to make or to create my own tutorial for you. You can see here after running the import statement, put clear screen as the first line in a cell. So that's why you will see that I have always this code line here, clear screen. So empty everything and start from a new screen. And I will show you step by step how to create this. Okay, so the first graph that you see here. So that's my first example. And the first thing that we need to do is to create a screen object. So the screen object, you can see here some comment that I put here. Okay, screen is basically a class. Okay, and if you follow my previous tutorial on how to make a Piedmontarian painting, now it should be more or less clear. Okay, if you uh, call a specific class, like in this case, screen, you are going to be able to create or to instantiate an object called screen. And that object will have some attributes and some methods that can be called on that object. For example, I can call the method background color and the method setup. And this will create a screen. Okay, so basically, if I run this, you see that I'm getting a screen. the background color is antique white, and I can change that. I can, if you put blue here, you are going to get a blue screen. And the setup method is simply a method which says, well, what are the dimensions of the screen with which I want to work? And 400 by 400 means that you are working on a space. And, I have, added this kind of thing here. Okay, so you can think of that space as, two dimension, x dimension and y dimension, and x goes from minus 200 to plus 200, and y goes from minus 200 to plus 200. So the dimension is indeed 400 by 400. So actually, you can think of it as a Cartesian plane, but I guess that more accurately, this is a space of pixels. Okay, I will talk a little bit more about pixels in my digital picture processing tutorial. But for the time being, you can just think of pixels as the smaller units in a digital picture. So, you could think of a pixel as a small little square, and, you have 400 by 400 little squares like that. But don't worry if you don't really get the idea of a pixel. We will come back to that in a next tutorial. So, basically, oh, by the way, again, for those who want to go further, if you go here, for example, and if you go to this module here, there are two files with extension py for Python. And if I click on that, you are going to see a lot of code lines, okay, and including one code line which defines a class for the screen. So that's what I call here, okay? When you see screen here, I'm just creating an object, okay, based on this code line that you see in the module per se, okay? And I'm not gonna go into the details of that. I just show that so that you understand that this is not really a black box, okay? When you write that, okay, you create an object based on a class and based on code lines that have been written for you. So you are using code lines instead of coding by yourself. If you look at that, there are many, many code lines in this program per se. Okay, I'm not going to go through all this. Just to show to people who are sometimes a bit you think, well, it's a black box, but I mean, the black box, yes, it is a black box, but there are code lines that explain what is done, basically. But for the rest of us, all what we are interested to do here is basically to create a screen object using those lines, and to apply some methods so that the screen object that has been created here, the screen object will have a specific color, antique white, and will have a specific dimension, 400 by 400 pixels. And then in the next stage, we can create a turtle object. The turtle object is that little turtle here that we are going to create. So basically, here I'm simply calling a class which is called turtle in in this thing here, in those code lines. I'm calling a class and I'm creating an object, and the object is a little turtle, and I'm gonna give it a name. Okay, the name I gave is Tolga. So I could have called it Theo or Patrick or T, sometimes capital T. This is simply the name that I gave to this little turtle that I'm creating. So that turtle is also an object which is created or instantiated through the class turtle. And then I can give, using some methods, I can give the turtle some shape and some color and some other properties. Here you can see that I have the shape is indeed a turtle, and the color is white. Okay, so if I run this, not only I'm creating a screen which is now black because I asked it to be black, it's still 400 by 400 pixel, or 400 by 400. The turtle by default is positioned on x0, y0 coordinate. So x0, y0 is just in the middle of the turtle. And the turtle is positioned so that the head is facing east, okay? And then, well, no, of course, you can change this, okay? If you want to have a background which is pink, when you create your screen object, you simply pass the parameter pink or the argument pink in the background color of the screen object, okay? If you want this to be a bit bigger, to give the turtle more space, you can put, let's say, 500 by 500 instead of 400 by 400. And well, I mean, when you create the turtle object, actually, it does not need to be a turtle. Okay? If you want it to be a arrow instead of a turtle, you can simply pass the argument arrow here in the method dot shape. And you are going to get an arrow as you see here. And you can also specify the color. It's going to be blue. Okay, so if I do that, that's what I'm getting. I don't have a turtle, I have a arrow, and the color is blue. And if there are other, there's also, instead of a turtle or a arrow, you can get the classic model, and you can try it. If you want to try it, you can do this. So you comment, you get rid of the comment, which is the Diaz. So, again, okay, I repeat, okay, when you have a Diaz or a hashtag like that, Python jump over it, like Python ignore the comment per se. If I get rid of that, it will not ignore it, it will read it. So maybe I can ignore this one and say, well, no, show me what is the classic shape, okay? And I can run that. And the classic shape is another type of arrow, but slightly different from this one here, okay? Again, it's very important that you understand that the DS or the hashtag that you see here is a way to introduce a comment so that human beings are able to read the comment, but Python does not try to understand what it means. It jumps beyond, above that, okay? So it's a way to introduce a comment without introducing a cell text, a text cell, I'm sorry. So now in our next step, okay, well, we have a little turtle, okay? I'm gonna start with that screen here and that turtle, and let's move it, okay? Let's try to understand how I can push the turtle, have the turtle move, and control its speed and the pen size. So basically, you can see here that I have created a screen with a specific color, black, a specific size, 400 by 400. I have created a turtle object, a little turtle that I call Tolga, with a specific shape, with a specific color. I have also introduced some pen size, and you will see, okay, it will control the size of the drawing that we are going to do. So we are going to create some drawing, and the size of the drawing, the width, you can control it, okay, or the size that we can control that. Okay, and we can control the speed with which the turtle move. One is very slow, so I'm gonna put one so that you see what's happening. And 13 is the fastest that you can go. And here you can see that to the object tall guy, so the little turtle, I'm applying, let me clear the output because I ran this file before. Forward means that basically the turtle is going to move in the eastward direction by 100 pixels. Okay, or you can think that if x was equal to 0, like here, x was equal, the turtle was here, and the head of the turtle was in that direction, now it's gonna move forward up to here, okay, when x is equal to 100. So let's try, okay? I need to run this thing here. And you can see that turtle is moving forward. Okay, forward here because the head of the turtle is by default in the east direction. Okay, and of course, you can have it go faster. Like if I put 5 here, it's gonna go much faster, and you can go up to 13, I think. Oops, I'm sorry. It's that's the penis size. Uh, that's the speed. Okay, so it's so fast that you even don't see it moving. Okay, and the pen size is basically the size of this thing here. So let's say that I put 10 here, you will see that the width is much bigger. Okay, and you can play with that. Okay, try to put 100, 200. And see what happens. Okay, I leave that to you. Okay, so pen size and speed. Okay, are two arguments that you can pass here in order to control the speed and the size of the trace that the turtle is doing. Okay, now let's have this little turtle rotate clockwise. Okay, so basically, from the point of view of the turtle with the head, which is here, okay, if I say, well, turn right for the turtle, it's going to be a move which is clockwise. Okay, so you can see that, and I can have it turn clockwise by 90 degrees, or by, degrees can go from 0 to 360, if you recall what is a circle, okay, in terms of degree. So let's have it turn clockwise by 90 degrees. So that's this command that you see here, okay? So that's the only thing which is new from what we did before. So let me clear the selected output and run it again. So you see the little turtle is turning right, okay? And now let's push it by, again, 100 pixel in the south direction, okay? Now, probably you have understood, okay? All I need to do is, again, I copy paste whatever I have written before. And now I'm gonna push it again by 100 pixel forward, so in that direction. And again, I'm gonna have the turtle turn clockwise using this operation here, or this command, dot right 90. Okay, so if I do that, here is what I'm getting. Okay, and now I can, of course, once you are here, you can ask the turtle, well, make the full square, okay? And you will not be surprised to see that all I need to add is basically, again, move forward by 100, turn 19 degrees, and then move again forward by 100 degrees. And I can ask, again, the turtle to come back to his initial eastward direction, okay? So again, maybe better if I start again on here what we have programmed. Um, So now you understand, okay, that actually little kids may be very happy to play with these things like that, because they, you know, eventually you get to understand you are able to control things. Okay. In a period where you have generative artificial intelligence and you can ask programs to do any kind of image. Okay, yeah, it's fabulous, and you can ask Gemini to do it for you. Okay, but there is some kind of satisfaction to see that you are able to do it yourself, to control it. Okay, and now, okay, let me introduce you some programming skill. Actually, once you understand, okay, we have been, those are those, it's always the same steps that you see. Move forward by 100 and then turn by 90 degrees. And we repeat that 4 times. So we can do a loop, okay? And in Python, it's very simple to do a loop. So that part of the program is the same as before. And I do a loop here. And the loop, look at the loop, okay? I simply put as instruction, well, Tolga, the little turtle, I gave it the name Tolga. Tolga is going to move by 100 pixel and then turn clockwise by 90 degrees. But I want the turtle to do that 4 times, okay? All I need to do is to write this thing. And this is very simple, okay? I is a iterator. It's an index, if you want, which can take different values. I can take values in the range from 0 to 4 by increment of step of 1. So it means that I is an index or iterator, which may take the value 0, 1, 2, and 3. Range is defined. It's a function in Python, so that the last number is not taken into account. Okay, so you go from 0 to 4, 4 excluded. So it means that you go from 0 up to 3, and by step of 1. Okay, so it means that fully I will take a value of 0, 1, 2, and 3. So basically for I taking value 0, do this. And then for I taking value 1, do this. Then I taking value 2, do this. And then for I taking value 3, do this. When it will stop once it has done all those 4 steps. Okay, so let's see what it gives us. Okay, I'm gonna clear the selected output and run that again. So see, it does exactly what we have done before. So those 4 lines here can be replaced by this loop. Okay. Well, now it's very simple if we want to have that little turtle to turn to do 10 full squares, so 40 movements. Basically, all what we need to do is to go from 0 up to 40 instead of up to 4. Okay, so basically here, the only thing that I have changed this A relative to A is that I have put, 4 has been changed to 40. So I is going to go from 0, 2, 3, 4 up to 39. Okay? Because 40 is excluded from the count with the range function. So let's try to do it. And I have increased the speed. But you can count, okay? It's gonna do 40 moves, and basically it means that it's gonna do 10 squares, if you want. Now, basically, we can also say, well, instead of having Tolga move by 100 constantly, we can say, well, let's increase the steps by which Tolga moves, okay? And look the way I have done that, okay? Instead of saying, let's move Tolga forward by 100, I simply say, let's move Tolga forward by 100 plus I, and it's in the loop. So, in the first move, Tolga will move by 100 because I is equal to 0. And then I will take value of 1. So in the next move, Tolga will move by 101, and then will move by 102 up to 139. So you already should get an idea of what Tolga is going to do. Okay, instead of uh, tracing a rectangle, you are going to see Tolga tracing actually bigger and bigger rectangles. So let's try to see what it gives us. Okay, I'm gonna clear the selected output and then do it again. So you can see that actually Tolga never goes back on its own steps or path, but the path is bigger and bigger. Now, maybe one thing that we can do is to say, well, instead of having Tolga turn by 90 degrees all the time, we can say, well, at each steps, every time I increase in the loop by one increment, by an increment of one, maybe let's have Tolga rotate by slightly more than 90 degrees. Okay, so let's try to see what it's gonna give us. I'm gonna clear the selected output, but you should try to think, before I run this, you should try to think, what am I going to get, okay? You can see here that when I asked Tolga to turn clockwise by now it's not 90 degree, but it's 91 degree, 91 degree. So the first time it's 91 degrees plus 91 degrees, it's gonna be 182 instead of 180, etc., etc. Okay, so you have to try to figure out what it's gonna give us. So let me run this. And you can see that actually Tolga is always rotating a little bit more than 360 degrees, actually 364 degrees, if I compute that correctly. So it gives us, a much nicer dynamic that you can see here. And we are getting closer to the kind of graph that we see here. Okay, so you can see that what looks like difficult to do is actually when you do it step by step, it's actually quite manageable. And quite manageable for kids. Kids learn that in primary school now. Next, what can I do with Tolga? Okay, let's give a different color to Tolga. Okay, one way to process is the following. Okay, there will be. I will give another tutorial on digital picture processing. Okay, so I will talk about pixels more fully in the next tutorial. But for the time being, the only thing that you really need to know is that to each pixel, you can associate a specific color. And, we learned that in primary school, that colors are basically generated by three primary colors, and it's a mix of three primary colors, like red, green, and blue. And those colors, and I will come back to in the digital picture processing tutorial. I will explain that further. But you can attribute numbers to colors going from 0 to 255. So it means that, for example, you can say, well, I want to have a value for the red of 95. It's a number between 0 and 255. For the green, I want to have 117, and for the blue, I want to have 48. And this mix of color will give you some kind of olive, dark green color. Okay, that's the mix of those three intensity of color for the pixel. And in Microsoft Word, you have the same thing actually. If you draw, uh, insert a text box and you draw the text box, and then you want to format the shape and to fill the shape with some color. I put the instruction here. You eventually you can select color, more color, and custom. And if you do that, you are going to get a screen where you can choose the red, the green, and the blue. And look, actually, I have chosen here in order to produce this color, I have chosen a value of 95 for red, 117 for green, and 48 for blue. And that gives me actually this color here, which is exactly the same as this one here. So again, don't be intimidated by whatever is done in Python. You do the same in Microsoft Excel when you want to fill some color to a specific shape, like here. And you can also notice that another way to express color is instead of giving some numbers to the primary color, red, green, and blue, there is something called an Hex number. Okay, so this is the equivalent of that. Okay, and I may talk a bit more about that in other tutorial, but for the time being, I will simply accept this definition of a hex number. So now let me give a specific color, that specific dark green color to the little turtle. So basically, instead of saying, well, the color of Tolga should be white, I simply say, well, R is equal to 95, G is equal to 117, B for blue is equal to 48. So it's specific numbers that you see here or that I have put here. And basically, when you call the color, the method dot color on the object Tolga, instead of passing the name of a color, you pass the three argument values, okay, or the three parameters values for R, so 95, values for G, 117, and values for the blue, 48. I could have written here 95, 117, on 48. Okay, so it's different ways to do things. Okay, so now if I run this, you shouldn't be totally surprised. Look what I'm getting: the same drawing, but the turtle is in that dark green color that we see. Okay, that's the same color as the one that you see here or the one that you see here. And remember I said that those colors, instead of defining them as red, green, and blue, you could define them as a hex, HEX number, and like I could do things like that. See here, I have put Tolga, the dot color method, and this thing here. So I can comment that out. So now it's an instruction for Python, and I can remove those. And let's run it, okay, to see what it gave us, So it gives us the same, okay? So you can, there are different ways to give colors to the turtle. One way is simply to put the name of the color, but with so many possible choice of color, think of it, okay? There are 255 intensities of red times 225 or 256, I'm sorry, intensities of green and 256 intensities of blue. So you can multiply those three numbers, 260 and 56 exponent 3, and that would give you all the color that we can create. Okay? That's a lot, many, many colors. So it would be difficult to give a specific name to so many colors. That's why we have to manage with either numbers or X numbers, as you see here. So maybe I can come back to this. I can run it again once. 10 times, so 40 moves. And you can see here that I have saved this, okay, and I gave a name, and it has been saved automatically here, okay, in this panel. Okay, so I close it and then I reopen by clicking on that, and you see that now, because I have this line here, I have saved a file, which is called Turtle RGB for those three parameters that you see here. And actually, it is saved as a SVG file. Okay, and SVG is scalable vector graphics. So, and we will see that again when in the next tutorials. I will have a tutorial on how to do some logo for websites, and usually logos are of the type scalable vector graphics. And this is not a pixel-based image format. You also have, we all know PNG or JPEG file. Okay, so those are pixel-based image, but the one it has been saved is actually called a scalable vector graphics. And well, basically, it's not based on pixel; it's based on a mathematical formula. And I will show you a bit later how to open the SVG file and see what exactly is saved. Okay, but I will do that later in the tutorial. One advantage of SVG format is that you can increase the logo of the graphs without losing too much resolution here. While you know that when you work with pictures and you increase the size of the picture, the resolution of the picture becomes less good with PNG or JPEG file. So that's why it's very popular with people who build a website, actually the SVG format that you see here. So once it's there, okay, you can always click here and download it into your computer and see it has been downloaded. And if I click on that, you can see that on my browser, so that's a browser, okay? On my browser, this is open. One of the problem of SVG files is that you cannot really open them conventionally. You have to open them in a browser. So, let me go back to my tutorial. Okay, so maybe, if you look at that and if you compare that with this, you can see here that I have changed the color constantly. Okay, how can I do that? So basically what you could do is basically to use a random number for R, G, and B. Instead of imposing that R, G, and B have those parameter values, we can draw them from a random number generator. So one way to do, basically, you will need to import a module from the basic Python library, and the module is called random. Okay, and basically the only thing that will change here, instead of imposing, well, I can still impose initial color for the turtle, say that the color is white. But then here you can see that in the loop, when I produce the loop, I can say the following statement here. I can say, well, R, instead of being R equal to 95, I simply say, well, let's draw R from a random number generator uh, in between the numbers 0 and 255, okay? And why 255? Well, that's the number that we have seen here, okay? Or that's the number, if you play with Microsoft, you will see that you cannot put a number, it must be an integer number, so 0, 1, 2, etc. And the maximum you can choose is 255. There are some reasons that I can explain later on when we will do digital picture processing. But for the time being, let's simply accept that the maximum you can use is 255. So for R, let's draw from a random number generator, let's draw a number between 0 and 255. And for G and B, same thing. Okay? And nothing has changed, okay? So basically, all you have to do is to insert that in the loop so that for each move, Tolga will change the color of the pad that the little turtle is tracing. So let me run this. And let's see, I can, again, clear the selected output and run it again. So you can see that Tolga is moving very fast because I have increased the speed to 13, which is the maximum. Tolga did 100 and did 80 moves. So I guess it's 20 rectangles. And for each of those moves came with a different color. So you can see that we are moving very close to this graph that we have here. The only thing that remains to be done is basically to increase the number of moves. So if instead of having a loop which goes to 80, you have a loop which goes to 400. So I will go up to 399. That's a mistake here. Then basically you are going to be able to generate the graph that we have seen above. Okay. So I don't do it here during the tutorial because it takes maybe 2 minutes for Tolga to make this graph here. Okay, but to make sure that you have a speed of 13 so that it goes faster. The second example that I would like to provide to you is basically to redo this little house, okay, that we did in Excel and in Matplotlib library in a previous tutorial. Okay, so let's try to see whether we can do it with the turtle module. Okay, so basically you will see that it's not very difficult. Okay, all what you need is again to clear the screen. You create a screen object, and I have put antique white here, so it's gonna look like that. This is the setup 400 by 400 pixel. I'm creating an object, turtle. I put a speed of 1 so that it goes slowly so that you can see what's happening. And here you can see that I have put some coordinates, and those coordinates are the values of x and y for the 10 point, for all the points that you see here. So -10 is this one here, and then 10 minus 10 10 minus 10 is the second coordinate, etc. So it's the x and the y. Okay, if you compare Matplotlib on Turtle, you can see that the way I'm introducing those coordinates is a bit different. Here it's a list of tuples. Okay, and tuples is another way to organize data in Python. I don't want to talk about that for the time being, but so the tuples that you see here are in rounded bracket, okay? But actually you could have square bracket as well, like this one here. You would be able to do it. So basically, I have introduced those coordinates, and then you can see here I said T pen up. Okay, pen up means okay. You have your pen down and you draw something, or you have the pen up and you don't draw anything. So what I'm saying and the name of the turtle here, instead of giving the name Tolga, I simply decided to call it T. Okay, so that's the name here. Okay, and you can give the name that you want. But once you have provided a name, every time you use a method, or call a method, you have to call a method on that specific name of the object that you just created. Here it's T. Okay. So I could have had Tolga everywhere, but I need then to have Tolga wherever you see the capital T. So T.penup simply says, well, turtle don't draw on the page or on the screen, okay? And instead go to -10, -10. And -10, -10 is this thing here. So basically, initially the turtle is centered on 0, 0 on our screen. Center somewhere just in the middle. And then you say to the little turtle, don't draw anything, but go directly to -10, -10. So go directly to here, okay? And then see pen down. So it means now, well, you have to go back on the screen, touch the screen, and start to make a graph, okay? And here you see simply a little loop like we have seen before, okay, for each of those coordinates, x and y. So x is the first coordinate, what you put on the x-axis, and y is what you put on the y-axis. So for x, y in those coordinates, so for this point, and then this point, and then that point, and then that point, etc. For all those points, go to x, y, okay? So basically, the little turtle will, with the pen up, go here, and then with the pen down, we'll trace this part. Okay, so let's see what it gives us. And then, I can say T hide turtle. It means that at the end of the drawing, you don't see the turtle. So clearly it makes the graph that we want. Okay, but the problem that we see is that actually this graph is very small. And it is very small because, it moves, remember the dimension is -200 and then +200, -200 for y and then +200. This is the graph that I have put here above. Those are but when we say to the turtle, go to -10, -10, it goes somewhere here. So it's, the distance is very small. If we want the turtle to do a bigger house, we really need to multiply those values maybe by 10 so that it will move to a bigger distance. And, that's what I do in the next slide or next cell, actually. I increase the size of the drawing, and you will see, well, nothing has changed here. But, instead of telling the turtle, go to -10, -10, I say to the turtle, go to -100, -100. So I have multiplied the distance that the turtle will draw. And here, the only difference with this is that I say that the turtle should go to x times 10 times 10 and y times 10. So instead of going to 10 and -10 here, after going to this cell here, which to this coordinate, it will go to this one, and this one is actually 10 - 10 multiplied by 10. So it's 100 and -100. And then it will be the same for all those coordinates. It will be amplified by 10 if you want. So again, if I gateway clear, selected output, and I run that again. That's what I'm getting. So you see pen down, so it does not draw anything when it goes from zero to minus 100, minus 100. And then the pen, or it's pen up, I'm sorry, and then pen down. That's what you see here. And then it draws the little house. And because I have T, so the name of my turtle, and I say hi turtle, that's a method which says, well, don't show the turtle at the end. Okay, so the turtle is not put at the end of the drawing. Now, if you want to fill the inside into pink, if you look back to my tutorial in Matplotlib, it was fill in pink. Okay, so if you want to do that, the only thing that you would need to do is, when you move the turtle to 100 minus 100, so this point here, okay, then pen down, and then you simply say fill color in a specific color, pink, for example. And then you say begin fill, and then here you say end fill. And this is basically the previous instruction. So before I had this, which was here, and I have simply put above the fill color. So I gave the turtle a command, put some pink, and begin fill and end fill here. Okay, and that will give me this. Okay, so I can do it again. And that's it. Okay, see how simple it is. Okay. We in the Matplotlib library, I added a door. It's easy to add a door. Okay, all I need is the coordinate for the door. And you can see here that I have added again some coordinate for the door in the same way as I added a coordinate for the house. And those coordinates are similar to those that I have introduced in the Matplotlib library. Okay, so I have introduced those coordinates, X and Y, for each of those coordinates for the door. So there will be a door like that. Okay, so that's the idea. And I have used exactly the same principle. Um, and so again, when you go back, when you have this program or Python notebook, look at that here. That's the way I have introduced the door. And if I run this, that's what it gives me. And the door is color in different colors. It's in brown. You can see here the color is brown. Okay, you could fill the door as well. I haven't done it, so I can remove this fill from the file. And basically that's it. We have order in the house. And remember, in Matplotlib, we have introduced some text annotation. We can do the same with Turtle. We can add some annotation, and the only thing which changed from the previous code cell is this thing here. Okay, so for example, the first notation on the top will be my house. And you can see that, all what you need is basically to specify a specific color, magenta, to specify to the turtle. Now, write something. Okay, so write what? My house. Always with quotation mark in between. And then you can change that. Okay, those are parameters values or that you can change. A line will align it to wherever the turtle is. So I say to the turtle, go to 0 to 100, which is a point like that here, and then write By the way, the setup is 400, 550. So the distance here is 550. Okay. You can as well choose a font, 40, Arial, italic, and things like that. Okay. And then I asked the turtle, go a bit below 010 and write welcome in navy color. And then go even below minus 200, y is equal to minus 200. And in yellow, write idea conception Patrick George, and then same type of ideas. And then, at the end, I asked the turtle, I have looked at the way the turtle was positioned at the start of the drawing, and then I have asked the turtle to do some rotation. So let's see, let me close this, clear the selected output, and let me run it again. And the last rotations that you see here are based on those directions that I gave to the turtle. And you can see that I have asked that this be saved under ours.svg, so you can download that. If you download it, this is what you are going to get. And actually, an alternative is actually instead of downloading the SVG file, you can ask, show me what is the SVG command. Okay, so this is the name of the turtle, and show SVG basically provides you this. Okay, and well, you see some instruction, you see that it has nothing to do with pixels. Okay, but one thing that you can do is the following. Okay, you can copy this. So Control C, and then in a Microsoft-based or Windows-based computer, you have something which is called Notepad. And in Macintosh computer, you don't have a Notepad, but you have equivalent to Notepad. So if you want to do what I'm gonna do with my computer, with a Mac computer, try to find on the internet what is the equivalent of Notepad. And it's probably already installed on your computer, but you just need to know what is the equivalent name of Notepad. So Notepad is this little program that I can open, and I can open a new window, and I can Control V, so I can pass whatever I have copied from this cell here. Okay, so here I simply say I highlight everything, Control C, and then I open this, and then I said Control V. And then what you can do is to save that as a SVG file. So this is a text file, okay? It's a text editor, okay? Which permits you to do a lot of things that you want, but you need to save it properly. So save as. And see, by default, it tells you, well, no, we are going to save it as a text file, TXT. But instead of saving that as a text file, let's save that as a SVG file. Okay, so I'm gonna say here all files. It's important. You don't want that to be a text file. And I'm gonna call that my beautiful house. And then I add the extension .svg. And maybe to avoid any kind of problem, I can maybe add this thing. Yeah, it's not necessary, but, and I'm gonna save that in my download file. Okay, so save that. And now I can go to my download file and see, well, I have a file that I just saved. It's 3:19 p.m. 3:19 p.m. I just saved this thing early, and now let me click on that and try the exercise by yourself. Click on that, and then you see that I have indeed this thing that has been open on my browser. Okay. So, and once you are, because somewhere, when you build a website, SVG files are very useful, but when you have a file like that, you cannot easily pass it to a Microsoft Word document. So maybe what you can do at this stage is always to print the screen. So you have probably on your keyboard, you have a print screen uh, key. And once you do that, like, let me do it, you can always, pass it into one of your documents. So here it's Microsoft. See, I have done it just before. Okay, so I can pass it again. Control V now, Control V, and that's what it gives me. It prints the screen, including what I'm recording now. And once you are here, you can always go to it's not like that. Format picture. And oh, I need to format picture, and you go to crop, I guess, and you can play with that thing. Okay, you can crop it as you want in order to make it uh, more suitable in terms of size. Okay, so now, oops, maybe now you have a nice little house that you can save as a PNG file. Actually, now you can save it as a PNG file, save as picture, and you can see by default it comes with a PNG extension, so that you can use it as a regular picture. Um, now, yeah, a little exercise for you, okay? And this is very simple. All I'm asking you to do is you start with a screen object. You give it a gray color, light gray or something like that. And then, your turtle, when you create your turtle object, it will be positioned here at x0, y0. And then what I'm asking you to do is have the turtle go here. And that point here is actually plus x is equal to, so that's when you say to the turtle go somewhere, you say t go to minus 150 and plus 150. 150. So the turtle will position here, and then just ask the turtle to do a square. So move forward, turn right, move forward, turn right. There are think about the dimension of the problem, Um and and then fill this in pink. Okay, so without showing you, I can maybe run this. Um, Well, I'm not gonna run it, okay? I don't want to show you the program, but because it's an exercise, but it's a very simple exercise. So try to do that, and that's it. Okay, so have fun with the little turtle and reproduce as many graphs as you want.